Hey everybody, this is Larry. This is day 6 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. I clicked on it. Let me know what you think about today's farm. Yes, sometimes people ask me why I click on this so that there's a luck thingy, so that you click on it and you get 10 coins. I don't know what you do, but do whatever you want with it. Today's farm is 1539 cave missing positive bit number, and it is an easy problem, so I am going to do a bonus problem, an extra problem if you want to follow along, something that maybe challenge yourself on a Sunday evening or Monday morning, depending on where you are. Hope everyone's having a great or had a great weekend and having a good week and all this stuff. Wow. Already first week of March. These days goes by quick. Anyway, all right, let's take a look. Cave missing positive number. Given an array of a positive integer sorted by a strictly increasing order and an integer k, return the kth positive integer that is missing from this array. Okay, let's take a look. I mean, it is sorted, so it's okay. I think there are a couple of ways you can do this. One is, I see the follow-up. I was going to say something like, there are a couple of ways you can do it, right? My initial thought is actually, to be honest, binary search. And we'll probably get into it in a very short while. What I think some part of it is, don't oversolve the problem that you have. I mean, if you give it, it depends on context, right? Like if I was in a contest, linear time, linear space is fine. I would probably just do like a brute force thing, and that would only do linear time, right? How is that linear time? Well, you basically just increment one at a time, and if and at first you just and because it is in strictly increasing order, you basically just go through all the elements, right? So you can definitely do that. And that's linear time, constant space. You can also put them in, just kind of. So that is a possible solution, right? And then you kind of just count up to k. It'll be maybe n plus k or something like this, or even just O of n if you're careful and just count it in a, count it correctly, really. Okay, so how do you do this in better than O of n? Well, the idea is about binary search, right? So the idea behind binary search is just that, how do I say this? So basically, the idea would be that given an array of length n for some n, if you're given an index I and it's strictly increasing order or positive integers, then if a sub I is equal to I, then no numbers is missing, right? If a sub I is equal to I plus 1, then you know that one number is missing or something like this. So then you kind of binary search to kind of calculate that, I think, and that would be fine. Yeah, because here we know that this is to the right of this, and then we could kind of just do some maths. I think it's, to be honest, I'm a bit worried about off by ones. That's why, even though my initial thought was binary search, I was actually gravitating toward the linear solution. But then, we might as well do it the smarter way. But yeah, especially on a contest or something like this, where the complexity might not matter as much, or rather, there's no difference between log n and O of n. I would most certainly do it the way that I think has less possibility for off by one. But of course, in this case, it's Sunday night. Let's play around, right? And then left is 0, 0, right is equal to and I know. Yeah, because we have to phrase the question. And what I mean by question is this testing of component of binary search, and we want it to contain the last number that is, we want a binary search that contains the last number, and I'm trying to be very careful so that it could be precise, the last number that contains k or less than numbers missing. I hope that I said that right. So yeah, so left is very good way. The way that I always say these are inclusive, and this n is intentionally bigger than the array in terms of index for inclusive intentionally, because it represents that, at least in my mind, maybe not, I don't know, maybe I'm wrong on this one actually, but it represents the last number that you can go. Maybe that's a little bit off actually. I think you need to represent this a little bit. I think actually maybe -1 and n-1 is more precise, because then now we can say that we want a number that's left of 0 to represent the last number or something, right? Okay. So then now, let's just say, I always just say if good, and this one is very easy to get wrong, so I'm not gonna lie, I'm not super confident about this, because yeah, but let's say middle, because we have to define this function so precisely, and this is k or less. If it's k or less, then mid is a good candidate, so then we want to go to the left, so we set right to the mid, and else is left is equal to mid plus 1, right? And that's not it. Oh, that's not the end of it. We have left as the last index, which is smaller, but then we have to do some maths with the array, like something like this, plus some like maybe something like the index, right? So that's number of missing numbers, and k minus the number of missing numbers plus this thing, and then you have to simplify it maybe, or something like this. This may also be an off by 1. I'll let the computer simplify it, because you know, but still, in theory, right? So this is a target, right? And this is just saying return r of target minus target is less than or equal to k. Something like this, but I feel like I'm way off by 1 possibility. Output is 5 but 9, so this isn't even close. But why am I All right, let's take a look. So am I answering the question correctly? So I'm outputting 2 for 5, so this is going to be 4 minus 2. So that means 2 numbers are missing. Why would it end here then? Am I doing wrong? Am I saying this one wrong? So this is basically saying, let me make sure that I didn't have an off by 1. It's possible to have an off by 1 here, because this is, because if 1 is the first index, then yeah, so this actually have to be subtract 1 more. I mean, it still is wrong, but at least it should be more precise, because the first number, yeah, first number is, yeah, okay. I think now this is more precise, but it's still wrong, so that's a little bit sad. Take a look real quick though. Okay, so at index 1, it thinks the number that there's 3 numbers missing. That's definitely wrong. Also, it's definitely wrong that we went to the wrong direction. Oh, I think I did the signs wrong, because if there's more, then we go to the smaller number. Okay, I think I just kind of it's very easy to get wrong, like I said. Okay, and now we have possibly an off by 1, but that's fine, because I think directionally we're a little bit better. This is really wrong though. Maybe. Let's see if I'm actually lying about this one. 3, 7. Okay, so it goes to 3 and it's a 7. So now we have 7 minus. I think this is wrong in that this should not be greater. It should be strictly greater than, maybe. But this is wrong. This side, it's possible that it's just off by 1. So yeah, it goes to the last index of 3. The way is 4, obviously. So I fixed this here, but I didn't fix this here. So this is this minus 1, but that means that the other number may be wrong, so I don't know. Like part 1 rather. Well, that's still wrong. Expected 6. Okay, so we have 3 and 4. So 4 is the last number. Maybe I don't do the last number correctly, but yeah, this is 0. So then this is k plus 4, right? Isn't this 0? Did I mess that up? Oh, jeez. Did I just mess a lot of things up? Why is... Maybe this is plus 1. The index plus 1. Yeah, this should be plus 1. I think I just kind of double negative myself. But then this is like... The other stuff is even more wrong, maybe. Okay. But I think this one being right is more important. And this one maybe it was equal. Okay. Now I'm just guessing stuff. All right, let's see. 4 and 11, right? That's not... Well, 11 at index 4. So it's 11 minus 4 plus 1. So that's 6. 6 is greater than. So that's not right. Wait, what was... Because then now this is true. So then it said, oh, I see. Because I changed the definition. Okay. Yeah, I forgot that I changed this definition and then my bounds were incorrect. So the reason is because if this is strictly greater than, we want to go smaller, but we also know that mid is false. Right, and also kind of, to be honest, I think I messed up this sign a little bit. I think I actually wanted this and then just like do this way, because that's actually the good part. If it's good, you try bigger. And I kind of confused myself, and I probably confused people at home, so I apologize for such a, and this is supposed to be an easy one. Let's give it some mid. I'm like 80% confident, and apparently not even. Oh yeah, because I didn't handle the -1 case. That's why. I mean, I put it here so that it is, so that I can handle it, but then I forgot. And you can kind of see it with whatever. I mean, any number should be fine, really. Or fine in giving me the wrong answer. Really? Oh, no. I mean, I think I got lucky here, but it should be, yeah, this is -1 and we don't handle it. That's why. So if left is equal to -1, then it should be just return k. Because then that means that the first number is smaller than k or something like this, right? Let's give it a submit. Oh, I got this one wrong again. Is there another reason why this is wrong? I thought that was the reason though, but maybe I don't realize. Left is 0. Why is left 0? Should be -1. Maybe my math. Oh, maybe for one element, this is just the bound isn't wrong, because this is already 0 and -1. So then this, it tests mid, and mid is in this case 0 and -1. No, this should be test 0. And therefore, a radius of 1. Oh, this is 2 minus 1. So this is good. So good is true. So we said, why is good true? Did I mess up? Man, this is very easy to get wrong. This is why I would not do binary search in a contest. But, okay. So this is saying that this is being a 2. Oh, I see. Maybe the way that I did it the other way was kind of more precise, but basically it's saying that there's one number missing, which, so I think I need to do this, not the other way. Okay, because the reason is because if they're equal, then I'm going left by accident, or I'm sorry, I'm going right by accident, because you know, that's not true, because we want the number where if it is less than k, so that we can add k to it, maybe. I don't know. I still am now not super confident about this, to be honest. So let's give it a quick submit. Okay. Yeah. How did I do it previously? Okay, I just got lazy previously. That time I got it correctly. Yes, I guess today it was just a little bit off. I don't know. I mean, this is binary search on the array, so this is going to be log n time total and all of one space, just because we go through all of them. But that kind of speaks to how really precisely you have to define your stuff. And I think this time maybe I shouldn't have. Was the -1 was kind of sketch. The way that I did it last time was a little bit better because basically I did it the other way where so the question is a little bit different where this is asking how many numbers I'm missing, and here I'm asking what is the last number that is less than k exactly. But if you ask that question just slightly off, it can definitely lead to just imprecision and off by ones, and that's kind of what I did. Hopefully this makes sense. Hopefully you learn from my mistakes. Yeah, that's all I have for today though, this kind of problem. So yeah, stay good, stay healthy, take good mental health. I'll see y'all later, take care, bye bye.